Welcome to your first video for Algebra 1. Today we're going to talk about order of operations. And a lot of you, well, what does that even mean, right? The order of operations. It's the order in which we solve problems, okay, in math. Order of operations, it's kind of like our punctuation rules for math, right? It's things like you use quotation marks to mean that someone else said something in English, right? But we just do that because a long time ago, people all decided that that was a good thing to do. In math, it's similar, but not exactly the same, because there's a reason that the order of operations are the way that they are in the order that they are in. And you might not have ever heard that. So today I want to take a second, hopefully not too many seconds, but just a few, to talk about why the order of operations are in the order that they're in. On the left of my screen, well, might be on the right of your screen, but whatever, this problem on your screen, my dad sent this tweet to me about a year ago, and it gave me a lot of questions, but I guess the one that he was asking me is, what's the answer to this problem? And I was kind of confused because it didn't seem like a big deal to me. But a lot of people on the internet, at least, because, you can argue about anything on the internet. A lot of people are arguing about this, saying that they got different answers. And so we need to be really sure that when I'm talking to you and we're talking about order of operations, that we're on the same page. Otherwise, if we're using different rules, then the math doesn't work, because we need to be speaking the same language, the same dialect. So this video is to make sure that we're on the same page. Okay, order of operations. Now, here is the order laid out for us. You may have heard it called PEMDAS, right? The P is for parentheses. The E is for exponents. M is for multiplication. D is for division. A is for addition. And S is for subtraction. That's the order that we do our operations in. But why is it that way? Well, you could think of it kind of this way. We start with the most basic operations, and then we build up to the more complex ones. Okay, what do I mean by that? Well, let's start with talking about addition and subtraction. I want you to think about these as the same thing, okay? So if I have something like 3 plus 7 minus 2 plus 5, the way that we usually solve our mathematical equations is from left to right, as long as there's not some other priority, right? Which is why we need to have the order of operations. But many of you might say, well, I need to make sure that I do both of my additions before I subtract. And here's what I want you to think about. 7 minus 2, that's the same as, 3, and then let's get a little crazy with it. 3 plus 7 minus 2 is the same as 7 plus negative 2 plus 5. 7 plus negative 2 is the same thing as minus 2. And so look, we're left with all addition. And now we would just go from left to right, because again, it's kind of like reading. We read from left to right. We decided as mathematicians, I guess we didn't, but some mathematicians a while back decided that Left to right is the way that we're going to do math. So 3 plus 7 plus negative 2 plus 5, or 3 plus 7 minus 2 plus 5. 3 plus 7 is 10. So 3 plus 7 is 10. 10 minus 2 is 8. 8 plus 5 is 13. So my answer then is 13. And the same here. 3 plus 7 is 10. Plus negative 2 is 8. Plus 5 is 13. Okay, so addition and subtraction, they have the same priority because they're really just two sides of the same coin. Let's talk about multiplication and division. Again, just like with addition and subtraction, I want you to think of these as two sides of the same coin. Okay, what do I mean by that? Well, let's take something like this. 10 divided by 5 times 2. Again, if you were to just go straight down the line PEMDAS, you might think, I need to do 5 times 2 and then 10 divided by that. However, can you think of another way that we could write 10 divided by 5 using multiplication? I'll get us started off. Maybe we can use, again, a different color here. 10 divided by 5 using multiplication. What if I told you it was 10 times something? 10 times what is equal to 10 divided by 5? 10 times 1/5, the fraction 1/5, is equal to 10 divided by 5. So, again, we would go from left to right. 10 times 1/5 is 2, right? 10 divided by 5 is 2, times 2 is 4. And that's different than if we had done these first, right? If I had done 5 times 2 first, that would be 10 divided by 10, which would be 1. And that would mean that we're not speaking the same language. We're not playing by the same rules, right? That's like me saying, I scored a touchdown and I get 10 points, but when you score a touchdown, you only get 1, right? That doesn't make any sense. We have to be playing by the same rules. So both of us just get 6 points when we score a touchdown, right? It's all the same. It's all fair. And we're speaking the same language. Okay, so that's multiplication. Now, why do we do multiplication and division before addition and subtraction? Well, I'd like you to think of this. Multiplication is just addition condensed, right? We kind of already said, I'm simplifying this a little bit, but we kind of said, okay, addition and subtraction, the same. Multiplication and division, the same. So I'm going to generalize and say multiplication is just condensed addition. If I give you something like 3 times 4, let's use orange over here. 3 times 4. 3 times 4 means I'm taking 3 4 times, right? That's why we call it times. So 3 times 4 would be 3 plus 3 plus 3 plus 3. 3 4 times is 12. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So multiplication is just condensed addition, which is why we prioritize it. Because if I say 3 times 4, what I mean is 3 plus 3 plus 3 plus 3. And again, to make sure that we're speaking the same language as math in order to play in this game, we decided, okay, 3 times 4 is what happens first because it's condensed. It's a condensed operation. I hope that makes some sense. Exponents, okay. Exponents come next. Exponents are something, if you saw something like 4 and then to the 2, right? That 2 is an exponent. So what does this mean? It means 4 2 times. So 4 to the 2, or 4 squared, is 4 times 4. Okay. This is huge. Don't miss this. If multiplication is condensed addition, then exponents are condensed what? Exponents are condensed multiplication, right? 4 to the 2, that's just a condensed way of writing 4 times 4. And kind of like we said earlier, 4 times 4 is just a condensed way of writing 4 plus 4 plus 4 plus 4, right? 4 times. So as we go up the ladder, it just gets more and more condensed. So the more condensed it is, the more priority it takes. Okay, so then that's exponents. It's what they are, that's why they fall that way. Parentheses. The point of parentheses is to say what comes first. An example. If I had something like, I don't know, 3 times 5 plus 1. Normally, using the order of operations, if those parentheses weren't there, we would do 3 times 5 and then add 1. But I'm putting the parentheses there to tell you, hey, 5 plus 1 is what needs to happen first. That is the problem communicating to you, telling you what needs to happen. Okay, so in this example, 3 times 5 plus 1, that would be the same as 3 times 6. And then we just multiply. 3 times 6 is 18. Something I want you to know, if you were to see, if you were to just see something like 3 parentheses 6, like this, it's assumed that we're multiplying, okay? 3 parentheses 6 means 3 times 6. So, I have no idea how long we've been going. Maybe too long. I want you to think about how to do this problem that I've given you. Use the order of operations and see what you come up with. Your task, maybe we'll call it, just your task, is to solve that. I want you to post your solution. And post your work to your solution. Explain it, right? Convince me of what your solution should be. I hope this video helped you out, helped you understand PEMDAS. And we'll see you next time.